UKRI. And welcome to this breakout session on cross-cutting interoperability challenges. We have 5 talks. You can see the titles there. I'll introduce each one in turn, so I won't go through them now. And we had about 65 minutes, which is now 60 minutes. So I'll ask speakers to speak for under 10 minutes, 9 minutes or 8 minutes would be perfect, so that we have time for a couple of questions, but we'll certainly have to move each one on after 10 minutes. So unless there are any questions about the introduction and how it will work, let's move on to the first talk. This is Fenix. About Fenix, a template for future e-infrastructure services involving HPC, and the talk will be given by Dirk Pleiter from KTH and Juelich.
Yeah, thank you very much for this introduction. If you could move please to the next slide. So I will start to introduce, say, the concept which is behind it, and I should maybe start by highlighting that this is work which, say, involves, say, a number of large-scale HPC centers around Europe. I mean, you see them a bit blurred on the in this right picture on the bottom. That involves BSC, CEA, France, Cinica in Italy, CSC in Finland, CSCS in Switzerland, and JSC Germany. And it is largely about also, say, the question of how can we transform supercomputing centers in the future towards becoming, say, service providers where HPC is only part of the resources which we are offered. And this is part also of, say, a picture on how we see in future science communities actually also using the compute and storage resources which are provided by us. As it is also shown in this picture, I mean, we have here on the bottom, we have then the e-infrastructure service providers, which are federated through a thin layer, which is shown here in a bit more red color. And then we expect more and more science communities to actually come up with their what we call platform services, and that is very closely connected also to the concepts pursued in EOSC. I just highlighted because that is basically from where we started from eBrains, which is an upcoming research infrastructure for brain research. So you could move to the next slide. So what do we have currently in place? Currently in place, we have, say, a few computing services and data services. And of course, in order to facilitate the federation, we additionally have then authentication and user and resource management services. Now, without going, say, too much into detail, I mean, the computing service, of course, they include still, say, the more classical HPC services, like what we call here then scalable computing services. But we also see an increased need of being able to use HPC nodes interactively. And we also start, and that has now meanwhile become, say, essentially kind of a standard, in particular in the EuroHPC context, also started to deploy what we call virtual machine services, which is essentially an OpenStack instance. Now, additionally, we're also providing data services, and here we introduced, say, an abstraction where, on the one hand, we have so-called active data repositories. You can think about them largely as being, say, the classical parallel file system with a POSIX interface. So nothing where you really are particularly suitable for a federation. And that's why we additionally put what we call archival data repositories in place. And these ones are going to be federated. For the time being, I mean, we foresee these being data repositories with a Swift interface, which are then integrated in the AI. And users can then use data transport services like the here mentioned data mover services to move data between the archival data repositories, which are federated, and an active data repository, which is essentially a repository for private copies of this data. You please go to the next slide. So this is a different view of this architecture. So again, you find, say, the different services which I have shown on the previous slide. However, what is highlighted now here is that these services are actually living in different environments. So we continue to have, say, the HPC environment, which because of also, say, for instance, dual use restrictions, is going to be a protected environment. And that's where we have, say, the scalable computing and the interactive computing services, as well typically the active data repositories, if you think about them as, say, large-scale parallel file systems based on Lustre or GPFS. But then we see more and more than data centers having additionally, say, a cloud environment with then an OpenStack instance with VM services. Now, how do we start to approach, say, this question of federation? I already highlighted that we have try to have a very lightweight approach, which makes it much simpler to integrate multiple HPC centers. And so it includes an AI service based on a central proxy IDP, and that follows the ARC blueprint, which was already mentioned in an earlier talk. And we have Géant as a subcontractor for this service. Additionally, we put also, an attribute service in place, again, following, also the ARC blueprint, which in this context in particular also has the role of providing, for instance, SSH keys, which you need for authentication with the HPC system. Move to the next slide, please. So now we are currently after CSC, so the Finnish supercomputing center, which is hosting one of the Euro HPC pre-exascale systems, became part of this club. Worked then with them, in particular with the Pura project, involving a few other Nordic countries, in further developing this concept by saying, okay, in the future, we might have what we call different infrastructure services domains, so that essentially domains which have a control on a certain amount of resources, like we currently have in the Phoenix context, largely based on the IC project from the human brain, has a certain amount of resources. And Pura is, the interface to Lumi. Now, what we would like to achieve, and that's where you have the direct connection also to EOSC, is that there is a common AI services layer, ideally then also operated by a neutral entity, where then different service providers organized in different infrastructure services domain can connect to, and then you connect to different identity providers. Next slide, please. Now, Phoenix, and that is, I think, an important thing to realize, Phoenix is not a priori a development project. It's not about coming up with yet another proof of concept of having a federated infrastructure. Our mission was initially through the IC project, which is part of the Human Brain project, to come up with, an existing infrastructure where you can apply for resources. And I give you here, an overview about the resources which are currently, available. For more details, I refer here to this link. Now, in the next slide, I guess I'm already a bit out of time because it's not shown anymore. Okay, so here I show that, how you can actually access these resources. We really, as an infrastructure service provider, we consider us as a neutral provider for the computer storage resources, and we try to delegate the decision on who gets access to these resources to others. And currently, we are focusing on an excellence-driven access model, but we are also available in the future to work on market-driven or wide access models. But currently what we have in place is essentially two excellence-driven access models. One is, a community-specific access model, which is run by the Human Brain Project, which provides access then for neuroscientists. But any else of you, assuming that you are, a European researcher, you can actually go to Praise and ask there for access to Phoenix resources. There's every 3 months, there is a call opening. The next call will close on the 9th of July. And so that's a way of how you can get access to this infrastructure. Next slide, please. So with that, I would quickly like to wrap up and summarize. So Phoenix is really, meant to be a long-term effort of supercomputing centers to provide a variety of e-infrastructure services. The resources are not limited to HPC, but also includes cloud type of resources. And we are, also available to evolve in the future. So an obvious candidate would, for instance, to add here, for instance, also container orchestration services. We also work here closely together with science and engineering communities, like, for instance, the brain research communities, to help them deploying domain-specific platform services. We started to put a lightweight approach for federation of e-infrastructure services in place, and that's where we also see, the close connection to EOSC. And final point, through the IC project, some of these e-infrastructure services are, already in place and accessible since 2018. Thank you very much.
Thank you very much, Dirk, and thank you for keeping exactly to time. So I think let's move on, if we can, with Diego Scardaci, who is going to talk to us from EGI and EOSC Future, who's going to talk to us about enabling the resource composability of EOSC. Go ahead.
Thank you very much, Juan. Good afternoon, everybody. In this presentation, I'll show you how EOSC feature is intended to enable the resource composability in EOSC. The EOSC feature is working on implementing the European Open Science Cloud, starting from some guiding principle. Our idea is that we don't have to create something from scratch, but we have to federate existing new infrastructure into a bigger system of systems. So the idea is that the different blocks that will be part of EOSC will be something that already exists, but EOSC feature will deliver the glue layers that would allow the composition or the integration of these different blocks across infrastructure. This will be done providing APIs, metadata, defining interoperability frameworks and guidelines, identifying portal capabilities that would allow to scientists to put together EOSC resources to create, I would say, added value services and solutions. In the diagrams that you can see at the bottom of the slide, there is a clarification about what I mean when I refer to EOSC resources. As resources, we intend any item that can be in EOSC that can be accessed, used, or reused, like services, like data processing services or automatic services, but also data set, software, publication, and so on. So I will use during my presentation these terms resources, but please keep in mind that behind the resources, we have very different kind of elements. Next slide, please. This slide shows the EOSC architecture as we envisaged it within the EOSC official project, and also taking into account the output of the EOSC architecture working group. And you can see there are 4 main blocks. In the center, we have the EOSC Exchange and the EOSC Core. The EOSC Core will contain the key functions to deliver the EOSC, both tools and coordination process, so like the AI, the service management system, the help desk, and so on. The Exchange instead will contain the resources that can be directly instantiated, accessed, and used by the researchers. In the Exchange, we have 2 kinds of resources: the horizontal resources that are made of services and data set that are independent by a specific sector, so can be reused in several scientific disciplines. For example, data transfer services and neutral services that can be useful to many communities. And on the top, we have the thematic services that are instead the user-facing services, the service that will allow really to perform science in EOSC. Then, in complementary to these 2 blocks, we have on the left the EOSC support activities like the training and engagement, and on the right the EOSC interoperability framework. That is a library of standards, interoperability guidelines, API interface that would facilitate the integration and composition of resources in EOSC. So the EOSC interoperability framework is the core element to enable the resource composition in EOSC. And in EOSC feature, we work to further define and develop it. Next slide, please. Okay, this diagram is quite complex, but this is also to allow you to have a better idea on the complexity of this kind of problems. We tried to identify different topology of services within EOSC, starting from the EOSC core platform, so the central function offered by EOSC, and other services like the infrastructure services, the thematic services offered by the cluster project, other research-facing services, and so on. Then we put everything together and we identified the different types of composition that we can implement. So we have identified at the end 4 different types of composition. Next slide, please. The first one is the integration, the composition between resources from EOSC that can be an horizontal resources or thematic services with a function offered by the EOSC core, like, for example, the integration with the AI. So an example can be protein visualization services that integrated with the EOSC AI, and this way the service will allow any user behind any EOSC user to access this service. Next slide, please. The second type of composition is about the integration of an horizontal added value services with a thematic services. So, for example, we can have material science services from a certain community that is integrated with an horizontal cloud computing services offered from an infrastructure, for example. Go next slide, please. The third kind of composition is about horizontal services. As I said earlier, each horizontal service offers some added value feature, like a data transfer feature of the orchestration on a cloud environment that can be used in many contexts. We can also put together more horizontal services to offer a powerful solution to thematic services and research community. So an example in this case of integration when a data management services from an infrastructure is integrated with some other data management functions from a cluster project, for example. Next slide, please. The latest type of the integration is the most challenging. It's about composing, integrating scientific services and data coming from different communities to create added value solution to handle complex scientific problems. As I said, this is the most challenging, but this is also one of the reasons behind EOSC, trying to allow different communities to work together and creating new solutions to deal with the new challenges of the science. So an example of this kind of composability is an epidemiological simulation service from a certain scientific community composed with a rich data set on logistic and international trade from other communities to help track the spread of a global pandemic. These are the four different types of composition. In EOSC Future, we are intended to work to enable at a certain level all these different type of composition. Next slide, please. And according to our technical roadmap, we would like to do it in an incremental manner. At month 6 of our project, that is means in the next autumn, we would like to allow researchers to access and combine EOSC compute storage resources with horizontal services. In addition to this, we would like to start to offer to researchers some example of a complex workflow made of resources coming by multiple providers. Then at month 18, the level of complexity will increase, and we would like to enable researchers to orchestrate data analysis on computing resources offered by multiple infrastructure providers. And in addition to this, we would like to allow the researchers to integrate their own storage system so they can feed data to the workflow and store the output of the workflow after the analysis is complete. Then at month 30, at the end of the project, we would like to reach a good level of composability within EOSC, and this will be achieved, first of all, associating a composability indicator to EOSC resources. This was what does mean. The idea is that we describe the EOSC resources, service and data set with some additional information that would allow the researchers, the EOSC user, to understand how these resources can be integrated with others. For example, the resource A supports the protocol X and the interface B, and so on. In addition to this, we would like to offer a rich set of end-to-end workflow from various research topics that the EOSC user can easily identify and instantiate and execute. And finally, through an execution framework, we would like to enable the possibility to launch virtual research environment on the fly, composing services from the EOSC resource catalog. Next slide. That's all from my side. Thank you very much for your attention.
Thank you very much, Diego. Again, exactly 9 minutes. There is a question in the chat which you could look at, and maybe if there's time at the end we'll come back, but we'll move on now just to make sure that we do get through all the questions, all the talks. Thank you very much. So the next talk from Giacinto Donvito from INFN is about EOSC-hub and the interoperability guidelines they have developed in that project. Go ahead.
Good afternoon to everybody. This is Giacinto from INFN. Hopefully you can hear me well. I guess so. Okay, so I will go into this short presentation about work that we have done during the EOSC-hub project in order to achieve interoperability guidelines. As you may see from this picture, the work done in the EOSC project has gone through different key exploitable results, and this is one of those that you see here. Interoperability integration guidelines, from our perspective, contribute to both the EOSC core and the EOSC exchange part of the ecosystem, EOSC ecosystem. So basically, we provide guidelines for both set of services. Next slide, please. Thanks. The most important benefit of this work was to give to the scientists, researchers, the possibility to compose services in a very easy way, taking those services from the EOSC catalog and marketplace, with the idea that they can rely on already compliant services that implement some basic functionality that they can reuse in order to compose those services and enhance the offering from the scientist point of view. The idea is that with these guidelines and these definitions that we have provided, the scientists and the developers has the possibility to use well-known APIs standard in order to compose those services. With this approach, typically we lower the barrier to allow the services to interact themselves and to try to build the new services on top of what we already are able to provide as EOSC. Next slide, please. We started from the building of a reference architecture composed by standard templates that we used in order to describe the functions that we see into the EOSC ecosystem at different levels. Those functions are defined as building blocks. So we define a building blocks with a set of capabilities, like which is the scope of that building block, which features to provide, which standard do it use, and which APIs are providing, etc. Next click, please. Okay, this is true obviously for the federation services, so the EOSC core, but also for all the common and horizontal services. So basically the context of EOSC exchange, but this is also true for the first set of what we call it in the EOSC-hub thematic services that are more research domain specific. Next click, please. Okay, so the reference architecture basically it's provide the same set of template for each of the kind of services we describe, and you see in the lower part of the picture the capabilities that we describe for each of the building blocks. So the scope, the principle, the policy, the main features, the standards, APIs, and examples of integration among services. Next slide, please. Okay, we provided quite a few of those template of those documents describing a set of functionality. We divided those building blocks in area, technical area, what we call technical area, that basically are collecting similar services together. So we have the federation, EOSC core services, AI, desk accounting, monitoring, security, software quality assurance, etc. And in the exchange, we have grouped like cloud infrastructure as a service, HPC, HGC, the data part, etc. And at the end, we provided kind of 18 different guidelines, and you will see those into this link from the EOSC-hub official website. Next slide, please. Okay, this is some examples basically where we describe the architectural part of some of those documents that we released. For example, here you see the AI, how it is described. So basically which services they can use as an information provider, or which kind of internal architecture each of the services has, or from the, I don't know, the help desk part, you see which kind of interaction it is possible. It is possible among the services, etc. So basically the idea is that we provide information on the integration functionality and how those, I see another slide, sorry, but I guess something, okay. And then basically which kind of functionality each of the services is providing. Next slide, please. Okay, so some numbers about the achievement of this work. Basically, we, leverage this work in order to support all the communities using the EOSC services alongside the EOSC-hub project. Basically, we had 35 integration achieved in the work of the thematic services, 22 in the competence center activities. During the early adopter pilot phase, we have more or less 9 different services using EOSC services already available, with up to 25 integration there, and exactly this was used also in the business pilot. Obviously, in order to do this during the lifetime of the project, we rely deeply on the work of the technical people that is supporting on the technical side those user community in order to implement those services for the first time, and then providing all those how-tos, guidelines, etc. It would be much easier in the future to do the same work with low effort in terms of technical support, obviously. Next slide, please. Okay, this was the idea. Hopefully I am perfect in time. If there are any questions.
Thank you very much. Indeed, you have got a couple of minutes to spare now. So let's see, there's been discussion in the chat about your timescales. And how ambitious your month 6 deliverable is. I wonder, does anybody want to step forward and ask a question either about that or something else? I think you can just turn on your mic and speak.
I see one question, how this work will feed into EOSC future. So obviously all the part related to the interoperability described for the EOSC core or EOSC core services, this is automatically somehow already available, and then EOSC future could leverage on that, building upon, improving this work. And indeed, the composability of the services that Diego was showing in the previous presentation was exactly the continuation of this work, improving the level of detail and the level of completeness that we have reached during the EOSC-hub project. So I see a perfect match, and the work has to be obviously improved as time passes, but the idea is always following those principles.
Thank you.
Indeed. Diego,
still have a minute. If we still have 1 minute, if anybody wants to say, or we can look, I can find how to scroll the chat, sorry. Yeah, anybody want to ask another question? No, in that case, let's move on to the next talk. And the next talk is from Leah. I won't even try to pronounce the surname, so Leah, please introduce yourself. And it's Leah's from CSE, speaking on behalf of EOSC-Nordic about the service interoperability framework. Go ahead, Leah.
Thanks, Juan, for the introduction. Hi, everyone. My name is Leah Riungu-Kalliosaari. I work for CSC, and this afternoon I am pleased to present the work we have done in EOSC-Nordic regarding the service interoperability framework. When we speak about interoperability governance, it's coined in 4 layers by the European Interoperability Framework, that is legal, organizational, semantic, and technical interoperability. Next slide, please. To begin our work, we did not want to reinvent the wheel, so we first looked at the interoperability frameworks that existed, which is the common one is the European Interoperability Framework, and then the EOSC Interoperability Framework, which was in the draft format last year when we did this work. The reason why the limitations we found with these 2 frameworks is that the European Interoperability Frameworks, it focuses mostly on public services and not so much on interoperable IT services for research activities. And then the EOSC Interoperability Framework was very good for data and related research artifacts. However, it did not have that much emphasis on services at the time. And also it didn't cover the legal interoperability issues. That's the draft format. But I'd like to mention that the second version, which was published in February of this year, has included some legal issues. Next slide, please. The methodology that we used for our work to develop the service interoperability framework, we started with the European Interoperability Framework, and we listed the principles and the interoperability layers, the conceptual model, and also the corresponding recommendations. Then we looked at those that the EOSC Interoperability Framework had developed, and we did an exercise of comparing the similarities and differences. And then we focused on selecting recommendations that would enable better alignment in achieving interoperability of services. And we came up with 6 categories that I'll show in a moment. And using those 6 categories, we analyzed or we assessed 6 cases in 3 different categories, 3 of which were HPC services, 2 were data management services, and 1 was a user and resource management service. Next slide, please. And here you can see the results and from our analysis. On the right-hand side of the matrix are the 6 groups that I mentioned we formalized. The core interoperability frameworks principles covered concepts such as openness, transparency, and reusability. And the generic user needs and expectations looked at user centricity, inclusion, and accessibility, for example. Technical and organizational interoperability looked at the use of APIs and tools to support searching of metadata. And then for organizational interoperability, we looked at aspects regarding the use of SLAs so that to ensure that users understand what exactly the service is doing. And under semantic interoperability, we looked at how well the services are able to support access to different data in different data formats and metadata. And under the conceptual model, we had 5 recommendations, and we then looked at aspects regarding to data quality, publishing of data in more like open formats and so on. In total, we formalized 21 recommendations, out of which we then created 35 questions. And those 35 questions, we asked them from the service providers. You can see the services that are listed there. 6 of them, 3 of them from HPC and 2 of them from data management services. And Puhuri, which Dirk mentioned, is the one that is should provide an interface to Lumi. And the services had limited and wide functionalities, along with I think that someone's microphone is on, and Rahim, could you please mute your mic? Thank you. So let me go back a bit. I was speaking about the service categories. We had the 6 services, and they were at different maturity stages. 5 of them were already in production, and Puhuri was still in design and development at the time. From the aggregates on the right-hand most column and the bottom-most row, we can see that the compliance levels are all generally on the medium level. And from our experience, this brought up a question as to the fact that when we develop frameworks, is it really possible or practical to have a one-size-fits-all framework? Because when you have a one-size-fits-all framework by design, it has measuring points that cannot be satisfied by all the services. And also, when you look at the actual compliance, it depends on how the users interact with the services. And I have to say that we didn't really have a strong user component when we were assessing the services. Next slide, please. How does this relate to EOSC development? We see some complementarity with the EOSC in interoperability framework because it focuses on data and research outputs, but our framework, we want to bring a contribution in terms of emphasizing interoperability of services. And the development of EOSC operations then needs a holistic approach to consider interoperability of data, research outputs, and services all at the same time. A first logical step would be to clarify the EOSC actors along with their tasks and their responsibilities so that we can achieve practical interoperability that takes both the end user and the service provider into consideration. Next slide, please. To conclude, the service providers demonstrated a high degree of awareness and insight and responsiveness towards the interoperability issues. However, we need to remember that comparing different services using a homogeneous set of questions can be difficult because the services have got different unique characteristics. In the future, this may be solved by maybe conducting analysis in the context of service types and user base. But such comprehensive analysis for further development would require a high degree of coordination. I think my slide something is missing at the very bottom, but I guess it's probably not that critical. But I think it was going to say that we should bear in mind to include the relevant stakeholders that should be involved. Okay. No worries. Yeah, practical interoperability. No, it was the next slide.
Okay, sorry. Now it's
no.
Oh, okay.
Yeah.
That's why.
Yeah, that's why. Sorry about that. I
no
guess
worries.
my bad.
Okay.
Yeah. No. Yeah. So in order for us to achieve practical interoperability, we should anchor the process in communities and making sure that everything is relevant and practical. Yeah, next slide. I think that was the next slide should be my last one, if I'm not wrong. Yeah, and this was not a 1 month job. So if you would like to read more of the service interoperability framework, please look at the report. I promise it's only, I think, 18 pages, so not very long. And then, and I'd like to thank the team that we contributed and wrote the deliverable. Thanks very much, and I'm happy to answer any questions. Yuan, if you're talking, you're muted.
Thank you. Yes, thank you very much, Leah. I think we will move straight on to the next talk now because we are on time. There should be about 10 minutes to spare at the end where we can discuss any specific questions for the speakers, but also some of these things that are coming up in chat, which are quite general about how interoperability is going to be achieved. So the next speaker is Hugo Labrador from CERN, and his talk is about CS3MESH4E0SC, which is a multi-vendor interoperability for research cloud services in ScienceMesh. Thank you. Go ahead.
Thank you, Juan. Can you hear me?
Yes.
Yeah, perfect. So hello everyone, my name is Hugo from CERN, but I'm also part of the CS3MESH4E0SC project. So I will give you a highlight about the multi-vendor interoperability for ScienceMesh and the European Open Science Cloud. Next slide, please. So a quick project overview. So CS3MESH4E0SC is a Horizon 2020 project for 3 years. It aims at interconnecting existing storage and research services to create an innovative collaborative mesh of application services, always supporting open source software, fair and open data principles. The artifact of this project is to build an operational, decentralized, federated infrastructure, what we call the ScienceMesh. And ScienceMesh will provide the building block for EOSC for the European Open Science Cloud. Next slide, please. So a key aspect of this project is that it's not creating a new community out of this federated architecture, is that it leverages basically on existing communities and especially on the CS3 community. So the CS3 community started circa 2014, just a workshop to gather people working on file sync and share services. And since 2014, we have representation in this community from research laboratories, NRNs, universities, companies, so accounting for more than 130 organizations, 30 operational service nodes, 25 countries. And if we add all the numbers from these already communities, we have more than 400,000 represented users, 16 petabytes of data, and addressing more than 3.5 billion objects. In recent years, this community has been extended to incorporate also another use cases like research and data services, which they integrate very often with file sync and share platforms. So this project, the ScienceMesh Federation, is building on top, next slide, please. So the ScienceMesh project is building on top of these existing communities to provide its core service and rely on decentralized operations. So basically all the sites have full site sovereignty and the data resides at their own sites. And the project relies on existing system fabric as much as possible to have basically a lightweight infrastructure. And by doing so, we federate existing large-scale operational data storage. And this is a step closer to bring EOSC to the end users. So users from where they are already and using familiar local services, they can also reach to remote users. We don't force users to export data to other applications, to other sites to reach a certain functionality. And we also have to integrate local processing workflows and existing on-site services with remote ones, for example, to unblocking like disciplinary research across different institutions, etc. The sustainability of this project is guaranteed by already building on top of an existing sustainable community, the CS3 community. And on top of this, we have also open rules for participation to encourage a wide and rapid adoption of new sites. Next slide, please. So I would like now to focus on the technical aspect about why interoperability is a key aspect for the ScienceMesh project and for the EOSC cloud. So in Europe, we have different isolated islands, different services at different institutions or services run by NRNs. So researchers inside each of these clouds can effectively collaborate inside of these islands. But when the collaboration is to happen across the islands, there are a lot of barriers because vendors have heterogeneous technologies and ad hoc APIs, and it's difficult to talk between each other. Next slide, please. So the traditional approach in industry so far is to introduce standard protocols, to identify standard protocols, to work towards standard protocols. And while this, from academic perspective and theoretical point of view, is the way to go, we know from experience that by having heterogeneous technologies, it takes years and substantial resources to basically implement the standard protocols across a mesh of different vendors. So to make them basically talk to each other. Next slide, please. So in this project, our proposal is to basically complement this traditional approach by introducing an interoperability layer, which is a platform itself. It's a software-defined platform that can be deployed on each of these sites of these isolated islands, and it acts like a translator. So while the vendors are learning and implementing the standard protocols using the traditional approach, these isolated islands and the researchers inside of these islands can easily connect to remote services without taking 2 years waiting for a solution for Europe today. And by having this IOP deployed, basically the sites can immediately join the ScienceMesh Federation ecosystem. Next slide, please. So a quick overview of what is this IOP interoperability platform. So it's a software component, something that you can basically deploy and run alongside your cloud infrastructure. It integrates with major enterprise file sync and share services like uncloud, nextcloud, and cFile. It focuses on solving the problem today while the vendors learn these standard protocols. And it allows to gradually introduce this native implementation of the protocols to the vendors. So we avoid a big bang approach. And this platform is sustainable because it's vendor neutral, it's owned by the community, and it's open source model behind. And the implementation of the protocols on the platform are well known in the community, like OpenCloud-Mesh and the CS3 APIs, which are also open source and driven by the community. Next slide, please. So what do you get by deploying the IOP? So by having the IOP deployed in your sites, we enable basically users to easily share resources with remote collaborators. And this is possible because there is a built-in mechanism inside this software-defined interoperability platform that implements a federated sharing mechanism with privacy guarantees via an invitation workflow on top of a node protocol, which is the OpenCloud-Mesh protocol. It also allows for cross-domain real-time document collaboration, integrating with real-time applications, very similar like to Google Docs, by still maintaining the full sovereignty of the data, because it's a very decentralized approach. The IOP also have mechanisms to reuse existing technologies like FTS, Rusio, rclone to transfer data from one site to another, because sometimes the use case requires to do so, like for example, moving big data sets to a HPC cluster for having a more efficient analysis of the data. The IOP also provides an optimized access to big data platforms like Jupyter Lab and Swarm. So basically, you can run your notebooks, but you can also share with them and run them on different clouds. And last and not least, the IOP has integration with traditional research flows for publishing, searching, and archiving in digital repositories, like, for example, Zenodo. Next slide. So if you want to dive into the CS3MESH, this is a couple of links that I leave here for further information, and I open for questions if there is time. Thank you very much.
Thank you very much, Hugo. That's very interesting. We do have 1 or 2 minutes specifically on Hugo's part before we move into a more general discussion. If anybody would like to ask, there is one very straightforward question in the chat. How would someone become a new node in the CS3MESH4E0SC system?
So the first approach would be to go to the documentation of the project, which is ScienceMesh.io. And there are guidelines and documentation about how to deploy the IOP and how to enable it in your system. For now, we have integrations with uncloud and nextcloud. So you need to be on one of these 2 systems to connect to it. And there is detailed documentation there. We are in the early phases, so we are looking for more early adopters to test basically the platform. So we are happy to have more people wanting to try, and also to go through documentation and give it a try.
Thank you, Hugo. Okay, so I think that's about the time on that. We have 10 minutes or so now for a general discussion. And I see there's been a lot of chat about how we are going to coordinate these various different initiatives. I mean, we've seen a couple of different architecture diagrams here. I don't think we've seen anything contradictory, but equally, I think we're a long way from having a single architecture that will enable interoperability across this whole. So I think there is a very interesting question about how we will coordinate efforts to make sure we get to that point. I wonder if anybody would like to comment on that subject. I believe you can just open your mics and comment.
Yeah, I was the person asking the questions there. Just because maybe I'm not so familiar with things. Yeah, I was just trying to see, and maybe this is really an evolving thing, how different groups would work together. The kind of like the task force that's going to be set up in the EOSC Association, particularly on technical interop, and then what the work is going on in EOSC Future, which I'm actually very pleased to have learned more about it this week, but looking forward to learning more actually about EOSC Future. So that was my question, particularly if there's an idea that the association group might have come up with the kind of technical architecture and then Future is doing the implementation. That doesn't seem particularly workable for me. I mean, it seems like maybe there's more of a feedback loop there, but I'm very interested in what people's thoughts are on that topic myself.
Yeah, so I'm happy to comment from an association perspective if that helps, and then I don't know if Diego or somebody wants to comment from EOSC Future. We definitely need to align these things. The association task forces will be a volunteer effort. I think within projects like EOSC Future, although you may have like externals who are volunteering, I assume there'll be project people involved in those as well. So my hunch is that there'll be a lot more effort available within the EOSC Future task forces, or certainly within the EOSC Future project, because people are funded to do that piece of work. So I would always expect that a lot of the heavy lifting or the the implementation certainly would happen within the projects. And I see the association task forces as a way to bring in the wider stakeholder community to help provide feedback on that, to give some kind of steers or endorsement or checks that what's being proposed by the project will actually work for the different research communities or for the different stakeholder groups. We have to make sure that we're not diverging and having different recommendations. So I get your point. If the association task force was defining an architecture that somebody else had to implement and they didn't like that implementation or that approach, it's going to be very difficult. So I think we have to be careful on that. There's some work that's come out already of the previous EOSC governance. There was an architecture working group, and there was some work that had come out on the technical architecture for that. But again, it was a lot of work that had come from the projects, because it's people who are involved in EOSC-hub and other projects that were within that architecture working group. So I think what we need to stress is that it's a kind of reciprocal thing. It's not one group telling another what to do. It has to be more of a collaboration and community consensus. And I think that's what Diego was reflecting when he was talking about the role of these different task forces and how they'll fit together.
Just as a quick follow-on, sorry, is the EOSC Future then kind of like the major driver of implementation here? There aren't any other projects which are going to be major drivers?
Yeah, so EOSC Future is a massive project. It's like 40 million. It's like the major investment. There are other projects. Obviously, you've got all the cluster projects. You've got Infra EOSC 7 projects. So you'll see lots of different projects represented at this event. But EOSC Future, I would say, is the main project, certainly that will be delivering the core and doing all of the like key implementation, but it needs to align with all of the other actors as well.
Thank you very much.
Do you want to speak? Say, yeah, go ahead.
Thanks, Sarah. Thank you very much, Sarah. I fully agree with what Sarah said. You don't have to see these two activities as something, I would say, working in separate silos. The idea is to have a strong collaboration, and the output from EOSC Future will become input for sure of the overall technical architecture task force in the EOSC Association. And more than this, very likely we will also discuss during the defining of this output with our EOSC Future. We will already try to get feedback from the wider EOSC Association group. So, and people from EOSC Future will be also part of the task force. Class that is technical coordinator of the EOSC Future with me is one of the chair. I also contributed to the charter of this task force. So you can see us two different initiatives working in parallel, but with strong synergies. One more focused on having something concrete, soon available, and implementing something that can be used by scientists. The others probably under the association looking more forward, trying to have an architecture that is, would say, more general, that also take into account future requirements, future needs, and so on.
Any comments from anyone not involved in EOSC Future, if there is anyone not involved in EOSC Future?
A comment, if that's okay, Juan. Just picking up on what Diego had said there. I think the key difference probably with the EOSC Association task forces is that it's not only EOSC Association members who can be involved in task forces, but I would see that it's maybe going to draw in a much broader range of stakeholders than an EOSC Future task force might, because the project's about implementation. So it's probably more, the technical groups or people from e-infrastructures and RIs, whereas the association, you may get people who are more, funders, policymakers, institutions. It might be a much more diverse range of stakeholders who are interested or involved in those groups. And as Diego said, I think it's probably looking a bit more at a high level and strategy, because one of the other things we expect the EOSC Association task forces to do is to help give steers through the association to the Commission, because we have to, say what should be in the next SRIA or give updates to the strategic research and innovation agenda. So really what we're looking at these task forces to do is a bit of horizon scanning and going, okay, we've got all this implementation going on. Here are the gaps. Here's where things aren't fitting together. This is what we need to prioritize. And that, in some senses, that happened on the last groups as well. There were things like, for instance, the PID policy actually got written by the working group of the previous governance, even though there were projects dealing with that. People from the Freya project got involved, but none of them had that as a deliverable, and we clearly needed a PID policy for EOSC. So the working group of not the association, but of the exec board picked that up. So I think where there's gaps, the association task forces may do a piece of work like a report or a policy or something. But I think in the case of like the technical architecture, I view that very much as the remit of EOSC Future, because that's a key implementation project that has all the effort to do that work and already has deliverables around it.
Thank you, Sarah.
Yes, sorry, just to quickly say, somebody who isn't a member of EOSC Future, but is kind of like a member of Elixir, and knowing that we have a bunch of services ourselves which already exist and of course have had a lot of interaction with EOSC, and of course they're part of the EOSC Live cluster, is that, yeah, it's clear kind of what's going on in EOSC Future, and that we can kind of stay aligned, even though I'm not sure how much of EOSC Live is actually kind of part of EOSC Future, that we don't get into a situation where EOSC Future develops some, because I fully accept, yeah, funders do it, and it's, it's really great being able to go off and create these services, but that there isn't some major incompatibility with what does already exist out there in terms of, at least in terms of this particular cluster services.
Thank you. Any comments from anyone else on this or another subject? We still have a few minutes. Any specific questions for any of the speakers? No, if there's nothing further, then we have got 4 minutes before we resume in the main room. So you can move over there and stretch your legs, if you like, before we start the discussion there. Last chance to speak. If not, then let's go back to the main room. Thank you all very much for what I hope was a very interesting discussion with a very broad range of different kinds of interoperability talked about. And I look forward to the next few years where we will see the all this different work come together.